Thank you for being here. I'm so excited to be here in Tel Aviv for my first time presenting. My name is Justin. I'm a security researcher at Microsoft, and I work in our threat intelligence division. So I work across all of Microsoft's products and data to identify and track threat activity, hoping to disrupt it and increase the cost for attackers to Microsoft's customers. I'm glad to see people came back from break. I was wondering how that was going to work out, so we'll jump straight in. So today we're going to be talking about a threat actor that Microsoft has named Strontium. Strontium is one of the busiest and most active threat actors we track within Microsoft. And they were responsible for a number of different threat activity or activity groups that we follow. We're only going to dive into one of these today with some examples. But there's a lot that you can dig into with these actors. They most commonly overlap with two other names that are common in industry, for APT28 or Fancy Bear. So if you're looking up other reporting or looking to get background on this actor, it would be good to dive into these various reports. Now, who does this actor target? This actor focuses a lot on Western countries, United States, Europe, but also in areas in Central Asia, South America, and some other geographies in smaller numbers. They do a lot of different sectors in targeting. They're interested in government and military organizations, anything that touches government organizations, which commonly is NGOs or IGOs or think tanks, defense contractors, primarily in the US and Europe, and then pretty much anything where there is a counter-Russia narrative, which is a really interesting strand of targeting when you look at this actor. That also extends into journalists, and other different smaller types of targeting. So we're going to talk mostly about a malware family today we call FusionDrive. It's also known as Trellix in open source reporting. FusionDrive is a lightweight tool that the actors use to collect system information and stage down additional code to compromise systems. The interesting part about FusionDrive for Microsoft is, if you look at the diagram, there's the actor on the top and the victim on the bottom, and smack dab in the middle is Microsoft. This tool uses Microsoft services and platforms to, in a fraudulent and an abusive way, in order to try to obfuscate and detection from the victim. This is a perfect opportunity for Microsoft in that it allows us to gain a lot of visibility over the actor and stay on top and detect that and do a global shutdown on this campaign. Whereas when they're not using our platform, we may be limited to other methods. So we can be very strategic here, and this raises the interest and priority of this type of activity. We're going to talk about several of these components for FusionDrive. Before going into the specific components, there's more. I'd like to give acknowledgments to a few other research blogs that have been put out on this. Some of this is going to be overlapping content from what's in these blogs. So this is really, really good background reading, or if you're going to go get additional information and you want to dive in for yourself, good place to start here. So in theme with the conference, we're going to go back in time. We're going to go back in time to November of 2021, October and November, and we're going to do that for a couple of reasons. Most prominently, that this campaign has a lot of publicly available information for people who are interested in this and want to look at this stuff after the fact. But also because it's one instance where Microsoft was able to investigate the entire length of the intrusion, from the very early stages to the very late stages with incident response and investigations. And we were able to put together the entire attack chain and show it in a very simple and exemplar manner. There have been several campaigns since November of 2021, all the way up until middle of 2022, and even continuing in different variants today. But this is the most, I would say, the best example end-to-end of what we saw with this actor. This is my mandated slide to tell you that we did, in fact, notify our customers when they are compromised or targeted on their online services. So if you are wondering if you were one of these people, you would know at this point. And this is something we do going forward. So we're going to start this campaign looking at the phishing email. So unlike the phishing training that you may receive in your organization, this phishing email actually looked really good. I'm a former offensive security engineer, and I spent a lot of time phishing organizations as part of my exercises and work. I hated phishing, and I hated phishing because to get it right, you have to get every detail correct. The slightest inconsistency will tip off a human, and once you tip off a human, you expose your most vulnerable point of your operation when you have no access. In this specific case, the email looked very, very good. It leveraged a compromised sender, which was a known organization that would normally communicate with the victims that were targeted in this campaign. It leveraged a known persona in that organization, an alias, and everything about this email, the signature block, the contact information they spoofed, the grammar, the sentences, it would all fit. This matched exactly the normal interactions that this account would have with these organizations. The email was sent to a number of organizations in Western Asia and Europe, particularly the Balkans. Attached to this email was this really horrendous budget spreadsheet. I'm very glad I do not work in accounting, because if this is what accounting looks like, I'll stick with computer code. In this case, the spreadsheet was not exactly being used for accounting. What most stuck out to us when we discovered this and started to do our analysis was that when you opened it, it immediately started downloading something else. And any time that you see Excel start downloading something else without asking you, that's bad. And so this jumped out to us and immediately triggered a priority analysis on behalf of Microsoft. And so you should be asking, where is the affectionate gold bar? Where is the thing that I have to click to allow content to run? And it's not here. And so when we start to dive deeper into the attachment, everything looks very benign, actually. There's no macros. There's no kind of traditional vulnerability vectors you would look for that's executing code. But there is one unique element of this code, and it was the implementation or the addition of something called a custom UI element. In Office, there is the ability to customize the UI through ribbons and other sort of vectors. And this custom UI element, this capability, follows the standard OpenXML schema. And this particular custom UI element was interesting because it implemented an onload handler, which means that when the UI element is loaded inside of Excel, it immediately triggers a callback to whatever is pointed at in onload. Well, as you can see on the screen here, the thing that is pointed at in the onload parameter is not actually local. It's hosted on a remote spreadsheet. And so when the document was opened, the custom UI element rendered and then downloaded a secondary spreadsheet. The interesting part about this was that secondary spreadsheet is not loaded inside a protected view, hence the no gold bar. And so when we discovered this, the teams across Microsoft worked to analyze this, and we got a CVE 2021-42292. And this was released very quickly after the campaign was observed in the wild. And the CVE, the vulnerability, is essentially that an external attacker can leverage custom UI features to load remote code outside of a protected view. And when you're reading patch notes, if you see acknowledgments and it says Mystic or Microsoft Threat Intel, that usually means we're finding attackers doing things in the wild, because that's our job. And in this case, we went live with this without providing a lot of the contextual threat information, because the campaigns were ongoing and we were working to disrupt the actor. But I'm here to tell you more of the story today. So in addition to bypassing protected view, what was notable about this document was that the actors gained an additional benefit by staging their malicious code, or multiple levels of their malicious code, not in the original phish. As I said, I hate phishing. It's a terrible, terrible thing to do. And when you're most vulnerable like that, you want to show as little of your hand as possible in the early stages. By doing this method of staging down multiple levels of code, it enabled the attackers to provide control over their secondary payload. That first document with the vulnerability, it had to call out to get the second document. If they monitored their logs, they could see anyone who was researching or investigating the infrastructure. They could see sandboxes detonating that may detect the activity. They may see victims who were just mindlessly trying to explore what just got downloaded on their system. But they can see it, which allows them an affordable control over that campaign. By getting that control, they can then protect the operational security going forward. And so they actually gained a lot of benefit through this staging process with Excel. Now, when you stage, you also introduce hurdles for sandboxes. If you can properly implement staging in your campaigns, such as in this case, sandbox tools may never download that secondary payload, depending on how they render documents. And that prohibits the effective detection early in the attack cycle. So this was the second document that would be downloaded and displayed to the user. There is no cool budget diagram in this one. It's just blank, which should naturally raise some questions. But by the time that this is loaded, things are not going well for the victim. And so naturally, the actor is a little less cautious here. Now, when we did analysis of this document, some really interesting things did in fact stand out. I can tell you that the victim that executed this document, their name wasn't Harry. And so it naturally begged the question as to why we saw paths for Harry. Seemingly, the attackers actually left multiple artifacts in this document from their build or developer systems, which were really interesting. One that they used the name of Harry. You can actually start to track build and development artifacts if you do this enough over time and over scale. And this provides a really interesting tool mark for the actors. Additionally, there was a string in the document that referenced an E drive, particularly a folder called office-v.5/test. It looks a lot like that this document was maybe part of some sort of builder and some sort of capability that the actor was using to generate these documents. Why is that important? It could speak to some sophistication and attribution elements. Naturally, if someone's just building a document by hand versus being provided a capability that builds custom documents for them with 0 days, it is more interesting and speaks to where this could have come from. Now, what did this do? This document did additional staging activity. So now we're stage 1 or 2, depending on if we start counting at 0. And in this case, the extra staging activity was part of an exploit chain for an additional vulnerability. Now, at the time that this was done in the wild, this vulnerability was no longer a 0-day. It was actually already patched at the very beginning of 2021. And so they were targeting users that were still vulnerable to this. However, this vulnerability, 2021-40444, it works inside of Perfected View. So when this vulnerability was released, the user would have to click Enable Content for it to work. So by chaining these two vulnerabilities, now the attacker effectively had a 0-click code execution on the system. This vulnerability is it's a vulnerability in the MS HTML engine inside of Office, and particularly it was weaponized here inside of Excel, but popularly when this vulnerability was released, it was most often seen in Word. And this vulnerability calls out and retrieves additional files from the internet, which then essentially trigger a certain file to be executed as a DLL, allowing for code execution. Now, really interesting is that a tool mark inside of this particular document and their implementation of this vulnerability was that they had a custom CLS ID here used, which was different than what we had seen in campaigns in the wild or in any example templates online. So again, another tool marker that really allowed us to hone in and track activity long term. We're going to do a quick demo. I'm not brave enough to do a live demo, so we'll watch our GIF play. In this case, I'm basically showing that this is a not fully patched system. This is a very old system, and that I'm running Excel with all of these standard things turned on. So you can see that we have prompts turned on. We have only the defaults, and Protected View is in fact enabled in this Excel instance. And so when I open the malicious document, the stage 0 that was attached to the phishing email, you can see that in the background, I immediately download another spreadsheet behind. You can see Wireshark fired a whole bunch of malicious activity, and then calc pops, 0-click, 0 interaction. Thank you. Don't thank me, thank Strontium. They gave us this entertainment today wherever they are. And so in this case, this is obviously a lab recreation of this vulnerability, so don't look at the IP addresses. That's not the real IP on the internet. However, it is a perfect demonstration of how this was happening in the wild and why this was so successful in the campaigns that we saw it used. So after they exploited CVE 2021-40044, we saw them then load something called FusionDrive. And FusionDrive starts with its own custom and implemented loader. So again, we're at stage 2 or 3. We're going on like number 4 here. It's getting deep. And this loader was a custom utility created by the actors, PE file, that essentially decrypts private key or decrypts a blob from memory using an RSA key. It downloads another stage from the internet again, so yay, more staging. Decrypts that with the key that it got previously. And interestingly, it does integrity checks. How many actors do you see doing integrity checks on their downloaded payloads to make sure that it's downloading the right thing and that it's downloading what they expected? It hasn't been tampered with. It's another kind of interesting marker of the sophistication or what this actor was worried about and planning for. After that, it just does some standard memory allocation and injection, ultimately resulting in the downloaded payload being executed. When FusionDrive is downloaded and executed, it immediately starts doing a deobfuscation routine. So it is naturally obfuscated when it comes down in memory. And it does steps to resolve the Windows API. It does this to avoid static analysis by endpoint tools, by not having those already resolved like in a standard functional manner. And then it eventually does a kind of brute force resolution of the offset of the embedded executable inside of this blob. So there's multiple stages and multiple levels of embedding involved here. But eventually, when it finds the embedded offset, it will then go ahead and execute that embedded offset. Now, this looks basically like every other remote access tool you've seen an actor use at a high level. It essentially does some things to make sure that there's no other versions of it running. Actors don't like when their tool has like 15 copies of itself running on the box. So they do things like creating a mutex. They go through the process of deobfuscating and decrypting all the strings that they don't want people to see with static analysis. In this case, it generates a unique bot ID using a very specific reg key in the registry that represents the machine that it's on. And then it enters a sort of endless loop in which it'll just continuously perform these activities. Now, inside of this loop, the malware will upload the system information on its initial run up to Microsoft's backend platform and services. So in the versions that we saw in 2021, this capability was abusing OneDrive. And it would use the Graph API inside of Microsoft, which is a unique API that allows you to interact across Microsoft services to interact with OneDrive. So it uploads the system information that it encrypted into OneDrive, and then it looks in OneDrive to see if there's a task available for it. And if there is a task available, there are only 2 tasks that were possible in this capability, a number 1 or a number 2. Not very cool of it. But in this case, you could either get more system information, check if anything changed, or you could execute yet another stage. And so in this case, it provided that capability. And as soon as the task would be executed, it would delete the task and post the task results to OneDrive. So essentially implementing a full command and control structure using OneDrive. Now, there are some interesting notable aspects of this tool that we like to walk through, and it's interesting because at a big level, this tool is actually pretty simple. I mean, it's a beaconing loop with 2 possible capabilities. And so when you start to get into looking at how do we know, like, after we have 15 or 20 copies of this, how do we still know that this is FusionDrive and not like another malware family from another actor? And there are some of these notable aspects that we rely on to do this. In one particular way, the way that this tool does string decryption was kind of unique. It's not fully unique, but it was notable. And the way that it does it is that rather than having a single XOR key that it decrypts, all strings with, it actually had a per string XOR key, and it would call their XOR decrypt routine with a different key on every string that was embedded into the file. That's not really effective against debugging or memory analysis, so maybe they were just trying to annoy the person using IDA. I'm not really sure, but with a little bit of IDA Python or a little bit of scripting, you can pull these all out. And you can see some of the strings that we can start to resolve by looking at this, some of the tasking results and commands. You can see the embedded user agent that it used for its communications. Now, what was really interesting from a engineering and attacker mindset perspective, that there were 2 strings in the file that aren't XOR encoded. So if you're naturally encoding everything, like why leave out 2? The 2 that they did not encode was the client ID and the refresh token. And the refresh token and client ID are unique credential values in Microsoft that are used to communicate via OAuth or establish authentication via OAuth to OneDrive. So we assessed that most likely the reason that these were plain text and not part of the compiled XOR routine was that they were using a builder, like we saw in the previous slides, to just stamp and patch in these values as they wanted to run new campaigns. Again, speaking to the fact that they have automation and code there built to allow them to continue to run campaigns. So when you look at the OAuth and graph interactions, this is what's most interesting to us, because this is where our opportunity space comes in and our ability to protect our customers comes in. Strontium leveraged fraudulently created, newly registered Microsoft Outlook accounts to build and create OAuth apps on our platform, and then use those OAuth apps to establish communications and authentication. So in order to even do this malware, they had to go to Microsoft, create an account, and create an OAuth application, and then generate a refresh token. So that process is really important because it provides us a lot of signals that we can use in the early stage prior to the campaigns even being launched to identify potential Strontium activity. Then they hard code these values into the FusionDrive malware, they authenticate, and they make all the calls to OneDrive. So you can see some examples of the URLs that they would pass to the Graph API in order to perform OneDrive interaction. And they always had this static embedded user agent, which again comes in very handy when you start doing analysis on graph data. So at Microsoft, a client ID and a refresh token, particularly a client ID, doesn't mean much to the average reverse engineer. But at Microsoft, we can peel that back a layer, and we can actually go in and look at the OAuth application that was created and who created it and start working backwards there. So our investigation took us down this road, and we identified Mr. Jeremy Vide at Outlook.com was used to create this particular OAuth application. It was created roughly a month or two there before the campaigns began launching, and was only ever interacted with from commercial VPN services. If anyone has ever tracked APT28 or Strontium before, that'll look really familiar because they carry out almost all of their operations using IoT devices or commercial VPN services. And so it started to help build toward that actor fingerprint that we looked for. There was a lot of other aspects of this account that were clearly fraudulent, such as the fact that it was created weeks before the intrusion. It uses commercial VPN for all its interactions, like we mentioned, and it had a burner phone number, all kind of pretending that they were located in Germany. Now, when this malware would run, it would generate system information. This is another unique aspect of FusionDrive in this routine that they use to generate system information. It particularly looks for 3 distinct steps on the system. So it will query all the running processes using the NT query system information function, which is interesting to see how they did that. It will pull the CLR, or the Common Language Runtime version of the system, essentially looking at what version of .NET you have installed on your system, which is important for them from for prevention or detection perspective. And then it will get your OS version, and particularly your patch version, and send all that up to OneDrive. When it gets issued the correct code, it essentially will pull that code down and just do a standard create thread crawl. So this is nothing too nifty on how they execute code, standard position independent code to create a thread. So the next stage that came down, yet another stage, after FusionDrive, this is what they would put on OneDrive and task for download. This stage was another portable executable file that allowed them to instantiate and run a .NET binary. And so essentially this was written in C++, and the C++ would instantiate a .NET runtime. It would extract an embedded blob and run that embedded .NET binary inside of the CLR, or the .NET run space. And this is a technique that's been popularized over the years amongst various offensive teams and penetration testers and red teamers. From there, the C# binary that was embedded was very similar to open source code that allows you to run PowerShell from inside of .NET. They modified some aspects of how they do this string base 64ing and decoding, which was unique enough to make it interesting, but nothing particularly special here. At the end of the day, this code essentially launches PowerShell Empire calling out to a domain that looks a lot like the first one, but note it's .org instead of .net. So they purchased two domains with the same top level. So what did we do with this? We talked a lot about malware and all this threat intel stuff, but the most interesting and most important part about this is how Microsoft takes threat information and leverages it to globally protect the platform. So moving beyond IOCs and fancy names and moving into hardening our platform, which is the most important thing. So before we do that, we saw a lot more FusionDrive. It wasn't just in 2021. We saw this used in 2022. Most notably, in early 2022, we saw another campaign using Office documents. In this case, it was PowerPoint documents, attempting to exploit a slightly version of CVE 2021-40444. At this time, it's pretty well patched. We don't assess that this was overly successful. However, it was interesting to see them continue to try to use that. And then after that, we saw them continue to deploy this tool actually interactively via other on-premises intrusions. So we start to see a merge between some of their exploit campaigns on Exchange and via VPN concentrators, and they actually start leaving this behind for persistence as a long hold capability, which is a big change to when they would just use it for initial access. And in this case, we saw this throughout Europe, and also in some of the operations we saw them carry out after the war in Ukraine. Now, Microsoft does have a history of chasing down actors that are using the Graph API and OneDrive and Teams, and we've been pretty vocal about chasing actors that do this. We've put out several blogs and tweets. A little backstory here, though, is that in 2020, the first time we ever started to investigate abuse of the Graph API, I mean, not the first time, but one of the earliest times we started investigating it, it was actually because of Strontium. And it was because of Strontium using PowerShell Empire with particular command control mechanisms that used Microsoft services. So Strontium started us down the road of investigating and detecting actors on the graph, and many years later, here we are continuing to detect them. But you should note that we've kind of gone on this journey of using the Graph API and the data that we have on it to detect malware. So what does that look like? What does it look like behind the curtain, one of the world's largest platforms to detect this? Well, it's not all that interesting, actually. It looks a lot like standard fraud and abuse. If anyone ever worked in fraud and abuse before? You got a couple people. It's a thankless job, so I thank you. It's one of the most difficult jobs coming from a security researcher perspective. When every day I look at a fraud and abuse problem, which threat actors are often a fraud and abuse problem at the end of the day. And this is very, very difficult to do due to the balance of maintaining the business and also defending your platform. In this case, the fraud and abuse triggers that most often fired on Strontium attributed accounts when we went back and did it were things like newly registered accounts that immediately stood up OAuth applications, only being interacted with from commercial VPN infrastructure with Python user agents, things like specific proof and backup details that never really lined up or enriched. When you enriched it all the different ways, it didn't make a lot of sense. And then interestingly enough, when they would create OAuth applications, there was something that was just special enough about how they created them that created an extremely high signal in our data, allowing us to work backwards retrospectively and create a detection going forward to identify these. Once that OAuth app was starting to be used in the wild, there was more data for us to look at. So we could look at the Graph API interactions for particular OAuth apps, and we would see things like periodicity, a kind of standard universal analytic that works well for command and control. There was a little bit of a sleep interval in this tool, but at the end of the day, when you have a victim that's beaconing out full speed all day long out to the Graph API, single OAuth app, single user agent, in very specific ways, it stands out quite a bit when you isolate it in the Graph API data. Again, they would also use OAuth apps with these kind of Outlook accounts that stood out. And then there were strong indications of control. So when you're looking at one OAuth application and all of its interactions are from one IP address in the world with a fake Firefox user agent, and then all of a sudden some Python stuff from commercial VPN, it creates a very strong indication that this is not legitimate activity. And it allowed us to start shutting these down in near real time. And so not only did we work backwards to find all these campaigns, we also started working forward. And every time we would see one of these registered, even before it was used in the wild, we could immediately terminate this for a fraud and abuse claim and feel confident about what we were terminating. And we were actually starting to get ahead of and control and prevent Strontium from using this ahead of time. So there, again, fraud and abuse is thankless. Sometimes cyber threat intel, if you're doing it right, it's also pretty thankless because the victim will never know they were about to be a victim. So we were proactive, consistent, and robust in working across these 2 years and into this year, disrupting FusionDrive activity. In some of these cases, we went from detection, with just finding in our platform, to notification. So again, anytime we find stuff like this, we do notify the end customer, and then building in actual technology preventions and fraud and abuse triggers to find this activity. Now, where does that bring us to today? So from August 22, when we're completely starting to shut this stuff down, we now see something new happen in a victim where we knew Strontium was, and we had been working to investigate and notify this customer. All of a sudden, on the same system where there used to be an old FusionDrive variant talking to OneDrive, there's this new FusionDrive variant, and we don't see it talking to OneDrive. And so we get naturally curious if maybe we're missing something. And we're able to identify a copy of this file that we're able to obtain. And in this one specific case, we found that it no longer used OneDrive. They altogether upped and changed their code and decided to move to Telegram. So this is something we haven't talked publicly about, but from at least in one or small limited number of cases, we've seen this toolkit be ported over to a variant that works entirely over Telegram. Which is interesting that they just up and moved to a new platform. I actually really thank them for doing that. It's nice. Now, this new variant over Telegram, why do we think this is still FusionDrive? Like, why are we still using the same name? Well, it's almost literally an exact code copy. It uses the same functional resolution, uses the same XOR stream decryption routines, uses the same exact system survey code and routines, the same 3 things, the same exact functions. They literally ripped out the part where there's OneDrive, and they dropped in a new library, the tgbot C++ library, to implement a new transport entirely over Telegram. So overall, it is basically the exact same thing as FusionDrive, just slightly shifted for the convenience of the attacker. Now, I will note that in this function, we do see a little bit of anti-debug and a little bit of a new anti-analysis features. Nothing significant, but it could indicate kind of that increased paranoia of just knowing that they're being tracked at this point and trying to do more work to make it harder for us. So I'm going to spend some time really talking about some of the big picture takeaways. Because this is really the point of this talk. We go back in time, we talk about all this old threat intel stuff, IPs and actor names and all these code words that threat intel people tend to use. And that's great. There is a lot of value in technical and tactical intelligence where we're sharing indicators and we're blocking those. But there's also a lot of value in recognizing the strategic implications of threat intelligence. Moving beyond just IOCs and even operational behaviors and patterns, and starting to look at learning from the actor to know what we need to do to make this not possible anymore from a platform or vector approach. What can we do at Microsoft or any other big technology vendor to take this from the actor, go to product teams and say, let's not let anybody do this, not just Strontium, but anybody. And that's a challenging thing. It's equally, if not more challenging than fraud and abuse, which is very challenging. And so I think that as an offensive security engineer, I used to find, I've actually done now 3 talks on using legitimate or cloud services for C2, or command and control. The first 2 was as an offensive person doing it and saying how awesome it was and how useful it was. And now I'm here telling you that I completely changed my viewpoint. I was wrong all those years. It's actually really not that great for the attacker to come to a well-resourced, large provider who invests in threat intelligence, who is going to find them quickly and is going to work to globally disrupt the campaign versus setting up their own one-off infrastructure. And so the message kind of is that platforms and vendors and technology is very uniquely positioned and strongly positioned to have a very positive impact on enterprises and consumers around the world. That includes everything from your large companies to the smallest of office shops that may need protection from various threat actors who are seeking to do them harm. And ultimately, learning from an actor and studying these actors and what they do is part of that. Because in order to decide and prioritize what you're going to change in your platform to make it more secure, you can look at the data in the real world and draw inspiration from these actors. The kind of second bullet takeaway would be that, again, I was wrong. I don't actually think using cloud services provides all that much operational security. It may protect you against the end victim should you get through on that first campaign, but ultimately it's going to bring intense scrutiny to everything you do from there on out. And it's going to cause a big loss and increased costs. And so the message to attackers is maybe a hopeful plea to recognize that stay away from Microsoft and OneDrive and go somewhere else, please. So, we talk about intelligence-informed defense. For those who may have to work an incident response for this actor, I did want to put in kind of a generic running list of my high-level wave of things that would be really interesting to look for if you're ever dealing with an APT28 or Strontium problem. I think if you were to look at this list, you would encompass a good percentage of the campaigns and investigations we've conducted. So again, noisy, low reputation infrastructure, or things that just shouldn't be talking to your boundary, that don't ever normally talk to your boundary. I know that's easier said than done in terms of identifying. Things like credential guessing on external public-facing services, access via single-factor authentication on VPNs or remote access solutions. They love to manipulate identities and post-compromise. Most often we'll see them granting application impersonation on accounts to allow them to access mailbox folders of interest. Again, this is a most likely information-motivated actor. They love to steal email. So we'll see that either via application impersonation or mailbox folder permissions. They love to collect data via legacy kind of Exchange Web Services activity, and so looking for that where it's non-standard can be very valuable, and we found a lot of investigations have used that. They love to exploit single-factor authentication. I cannot say that enough. Almost every intrusion from these folks turns into access to a VPN concentrator or remote access in some way after they obtain credentials. So it's an absolute must find for them. And then much like many of the actors nowadays, they leverage or incorporate lots of different open source tools. Most notably, Impacket is one that we see consistently throughout intrusions from this actor and other actors in a similar nature. So we're going to be toward the end. I don't think we're taking questions, but I just want to say again, thank you for hosting me in Tel Aviv, and I hope this was informative. Happy to talk to you outside.